Okay, in this problem, we're asked to evaluate the limit as theta goes to 0 of the quantity 1 over 2 plus sine of theta minus 1/2, all divided by sine of theta. Now, we should always plug in the value that we're approaching just to see if we get lucky and we get a number that is not 0 over 0 or infinity over infinity. So when we do that, though, we have a problem because sine of 0, I should say, is equal to 0. So this becomes 1 over 2 plus 0 minus 1/2 all over 0, which is clearly 0 over 0. Unfortunately, we cannot immediately jump to undefined because we don't know if the limit is different approaching from the left or from the right. We can't say that that limit is going to 0, and we can't say that that limit is going to infinity just yet. So we have two options. We can use L'Hopital's rule because it's in the 0 over 0 form. I'm not really excited about L'Hopital's rule for this particular problem because of that derivative right there would be a little bit ugly. So I'm going to try to use some algebra first before I resort to L'Hopital's rule. And whenever I see fractions, the first thing I want to try to do is write everything in one single fraction. So let's start with this. We have the limit as theta goes to 0. My handwriting is so bad in this program. I apologize. I'm going to take the sine of theta in the denominator here and factor it out front as 1 over sine theta times. Okay. Now in this set of fractions in the numerator, they have a common denominator of 2 from this 2. That's getting ugly, so I'm going to erase that, times the quantity, this denominator, 2 plus sine theta. Okay. And then my numerator will be this fraction needed the 2, just the 2. So 2 minus this fraction needed the 2 plus sine theta, so 2 plus sine theta. All right, and let's see, let's do some cleanup here. We have the limit as theta goes to 0 of 1 over sine theta times 2 minus sine theta over 2 times the quantity 2 plus sine theta. Okay, so this is fabulous because those 2's are going to cancel in the numerator, and what we're left with is the limit as theta goes to 0 of negative sine theta divided by sine theta times 2 plus sine theta. Now this is really great because now these sine thetas are going to cancel. So what we have here is the limit as theta goes to 0 of negative 1 over 2 times the quantity 2 plus sine theta. Just barely fit that in there. Okay. After you write things as one fraction, as one single fraction, and you get some canceling, anytime you get canceling that we have right here, I'm going to plug theta equals 0 back into my limit to see if I got lucky and things reduced. And sure enough, remember, sine of 0 is 0, so this is going to be negative 1 over 2 times 2 plus 0, or negative 1/4. Wow, I barely got that in there.